supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
How do you hold on to something that keeps slipping the net? All week, 3I Atlas has ducked under easy answers and surfaced where no one expected. A visitor from another star, quiet and fast, crossing our lanes and refusing to be caught. We planned for a clean check-in around Mars, a turn near the sun, a polite wave on the way out. Instead, we got cut feeds, a rod that wasn't a rod, and a sudden green flare that shouldn't have arrived yet. The third interstellar guest feels stranger than the last two. The timing looked perfect. On the 3rd of October, the comet brushed past Mars at about 0.19 astronomical units, approximately 17.7 million miles, close enough for our emissaries there to take a front-row seat. The Mars Reconnaissance Orbiter with the high-resolution imaging science experiment camera, and Mars Atmosphere and Volatile Evolution Orbiter, both had a clear line of sight while Earth sat in sunset glare. Then public streams went quiet. A US government shutdown paused routine NASA updates, and a flood turned into a trickle. The spacecraft kept recording. The silence was ours, right when the view peaked. At the same time, a Perseverance rover frame made the rounds, a tall silver strip as if the comet had stretched into a gleaming pole. Dramatic in a thumbnail, ordinary in the details, cameras draw with time, track the comet and the stars smear. Scan the scene while the comet moves and the comet smears. A rover navcam builds an exposure across an interval, so the comet crawls across the detector while the picture is read. Hubble has produced the opposite look. Comet sharp, stars streaked, because it locked onto the comet. Stretched light explains the rod. Then came the eclipse. The night of the 7th to 8th of September, under a blood-red moon and the darkest sky they could find, two veteran astrophotographers in Namibia pointed toward 3I Atlas and caught an emerald coma. Green happens when sunlight energizes diatomic carbon. The surprise is timing. Spectra from July and August showed those carbon bands weak to absent. While carbon dioxide dominated, water lagged, carbon monoxide hummed along, and pinches of carbonyl sulfide and cyanide joined the mix. The rulebook said, "Not yet." The frame said, "Look again." Maybe new active patches woke up in early September. Maybe eclipse light and processing nudged colors. We'll know after conjunction when fresh spectra arrive. If green persists, chemistry changed mid-story. If it fades, the images will stand as beautiful puzzles and will turn the page. Beneath the color is an odd recipe. The asteroid terrestrial impact. Last alert system tagged the object in July. The Zwicky Transient Facility pulled pre-discovery frames. The Transiting Exoplanet Survey satellite found it in May, faint but already active, ahead of the usual schedule for comets that far out. When Hubble got a clean look on 21st July, it set a firm cap on the nucleus, under about 5.6 kilometers across and likely much smaller. The Minor Planet Center stamped the interstellar designation. On the 6th of August, the James Webb Space Telescope listened in the near-infrared and heard carbon dioxide pouring off in abundance, roughly 8 parts CO2 to 1 part water, with carbon monoxide present but not driving the show. Cyanide arrived later and strengthened week by week, a small nucleus with a big upside-down balance. The metals added another twist. Through July and August, the Very Large Telescope saw bright nickel lines, while iron stayed quiet. In many comets, those two travel together. Here they parted ways, and they did it far from the sun's furnace. One calm explanation. Some nickel sits inside more volatile compounds and lets go sooner, while iron clings to tougher grains. Dust physics offers another. Grain sizes and shapes can bias what we see, letting one element stand taller than its partner. Either way, nickel sang early. Light itself delivered a fresh signature. Polarimetry teams measured a deep, narrow negative branch, the kind of scattering we associate with very cold outer system surfaces. In plain terms, the dust grains look icy, skinned in dark organics, and arranged in a way rarely measured in a warm, active coma. A far rim accent inside a near-sun scene. Motion should have been the quiet chapter. Outgassing acts like a set of tiny jets and nudges a comet's path each day. 2I Borisov wandered by tens to hundreds of kilometers daily. Hale-Bopp did more than 10 despite its bulk. Oumuamua showed stronger shifts in places. 3I Atlas has traced a remarkably steady line, often changing by only a couple of kilometers per day or less while already active. That calm birthed a rumor during the Mars pass that it had stopped. The measurements don't agree. Different stars, stacks, and instruments can hide small night-to-night shifts to the eye, but the path stayed true. Poise can be natural. The shape of the haze matches the story. In July, a sun-facing plume showed up near the nucleus as dust lifted from the lit side. As weeks passed, the classic tail sharpened in the anti-solar direction, while a faint fan remained on the day side. That fits a CO₂-rich coma, waking before water takes over, and fits how our viewing angle changes which feature stands out. Test supplies a prologue. It recorded 3I Atlas from 7 May to 2 June, weeks before discovery. Stack those wide-field frames, and the comet brightens by a factor of 5, not the gentle 1.5 you'd expect from getting closer. That suggests activity near 6 astronomical units, approximately 558 million miles, out where water sleeps. Hypervolatile ices were breathing first. The May-June light lines up with what Webb heard later. Sometimes stories wait in old data until we know where to look. Here is the arc ahead. The turn near the Sun, perihelion, arrives on 29th October at 11:44 UTC, near 1.36 astronomical units, approximately 126 million miles. Hubble and Webb must look away for safety, so Mars carried the early baton and the space observatories return after the glare. In early November, the comet sweeps wide of Venus near 0.65 astronomical units, approximately 60 million miles, as the geometry softens. On the 19th of December, it makes its nearest pass to Earth at about 1.8 astronomical units, approximately 167 million miles. On the 16th of March, 2026, it brushes Jupiter's neighborhood near 0.36 astronomical units, approximately 33.5 million miles, and then thins into the dark between stars. No danger along the way, just a traveler keeping its appointments. Planning to look yourself? October belongs to Mars. Let the orbiters be your borrowed eyes. By mid-November, try thin pre-dawn windows as the comet eases out of the sun's glare. December is friendlier, with evening chances. An 8 to 12-inch telescope or a small smartscope will do more than the naked eye. Let the sensor breathe, stack gently, and watch the grey smudge lean into a direction. Hold a few quieter notes. Cyanide has strengthened since late August, a classic sign of water ice grains sublimating in the coma. The dust tail has stretched dramatically since July, proof the comet is answering the sun as physics demands, even if the mix of ices is unfamiliar. These are the steady instruments under the headlines. And then the coincidence everyone likes to test, the famous WOW. Signal in 1977 came from the general direction of Sagittarius. Track 3I Atlas backward and it rises from that side of the sky as well. Think of it as a rhyme rather than a verdict. Be curious and cautious in equal measure. So what qualifies as even stranger right now? The emerald flare under an eclipse when earlier spectra said the carbon lines were quiet. Nickel standing tall while iron stays muted, long before the heat. Dust that polarizes light like a distant ice world while working closer in. A calm, steady course during a season that usually looks jittery. A Mars balcony spoiled for the audience by a budget fight right when the view peaked. And threaded through it all, a faster response from us. Inbound detection, coordinated instruments, and a plan to meet the comet again after the sun. From here, the steps are simple. Let late October belong to the sun. In November, gather fresh spectra and cleaner angles. Ask the green to declare its source. See whether the metals rebalance. Listen for water after the heat. Then mark one quiet night. 19 December. The comet will be as near as it will ever get to our street. No sky-wide sword. A soft blur with a direction. If you let the camera breathe, You will hold a traveler from another neighborhood on your sensor for a minute or two, and the universe will feel one shade larger than it did before.